Hello, my name is Jordi Cenzano. I'm an engineer at Meta, and this is my second time here in Madrid, so thanks for inviting me. So today I'm going to talk something that is very different from my first talk. My first talk was about media per quick, if I remember properly. This one is about AI, so one of the hottest topics I think in the industry. And I'm going to talk about Meta AI translations. So let's start. Let's start with this video. Soy ingeniero en Meta. Okay. Y estoy aquí en Madrid para presentar cómo funciona.
Porque lo podemos mandar por el HDMI.
Ok.
No sé cómo.
Espera.
Lo quito aquí. Sound.
Ok. Vamos a ver. Sí. Hola, mi nombre es Jordi Cenzano. Soy ingeniero en Meta y estoy aquí en Madrid para presentar cómo funciona mi trabajo de producción. Okay, now let's see this second video, this second recording. Hello, my name is Jordi Cenzano. I'm an engineer at Meta, and I'm here in Madrid to present how AI translations work. Okay, now very short quiz. Which one is AI generated? Okay, was pretty clear because of the end of the video. Yes, you're all right. So the first. But okay, I would say it's, apart from the last sentence, that was the clue, I think that everybody picked up that was AI generated. I think it was quite reasonable quality. So basically this is zero human effort. It was all generated. I recorded this once, click a button and get the other one. So this is AI translations. So first of all, I want to start the talk saying that this was a huge project at Meta. A lot of people involved from all of those organizations. I'm in the video infrastructure one. And I want to also thank Amisha and Sravan so that they helped me to put this presentation together. So I'm just one of those tens, if not hundreds of engineers that was involved in this project. Okay. So let me give a very quick introduction about AI in the media world. So there are AI models applied in the media world since a few years ago, I would say several years ago. And the first ones probably were the ones that inspect media. So you can provide an image or a video and they can inspect it and give some metadata or some text or metadata about that. It could be an image or video, as I said. It could be an audio and give a transcript. So audio in, text out. There are other types of AI models, and those are more recent, that can generate media. You can give a prompt, and they can give you a video or an image. And there are other types that modifies the media. You can give this image and with a prompt or just with a point in those balloons, and then the algorithm can detect that that is a balloon and remove it and fill the background. This modifies the media. Or you can send an audio WAV file, a PCM audio in Spanish, and return a PCM audio in English. So obviously we are going to focus in this talk with these algorithms that modifies the media. So and here I'm going to talk obviously about the internals, about presenting block diagrams and all of this that the engineers do. But first of all, let me show you the feature from the user point of view. So this is what the users see, and this is why us engineers work. So this is my Instagram. And I try to publish a reel, I select a video, okay. Hello, my name is Jordi. Blah, 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 blah. And then I click publish. I only share with one people because I don't want to spam all my feed. And I click translate voice. And I just need to click, I want lip syncing, and I want to translate to, in this case, to Spanish because the video is in English. And just click share. This is all. This is all the users have to do to access to Meta AI translations. By the way, if you try right now, so probably you will not have yet access to this feature because we are doing a small rollout. But a lot of people around the world already have access to this feature. As you can see, it's just with a couple of clicks, you can reach a much wider audience because now you can reach more languages than the one that you are posting. Okay, so now let's go deeper. So we are engineers, so we love block diagrams. So let's see first a high-level block diagram about what you just saw, what involves. So all starts in my device, in my Facebook, or this is available in Facebook too, or my Instagram. I have my content, in this case in English, and I want to upload it. So basically I create this media and I upload this media via internet to a distributed storage that we call OIL. So this is, we have open talks about that. And then I sent a request to the data model, identifying I'm Jordi Cenzano, I want to translate this to Spanish. We have a lot of pools of workers, some of them AI enabled, others don't. And then this request ends up in one specific worker that is AI enabled with some models load. This worker downloads that media in English. It does a lot of magic that we are going to explain, more or less. And then it produces the media in Spanish. And it seems that this is all. No, this is not all. And then this media has to be consumed. I have a user from UK with the device in English. We are going to serve English content, always. We prefer always original content. But if the user has the device in Spanish, and it happens to have the auto-translated content, translated plus lip sync content in Spanish, we are going to and the user did not opt out of this feature, we are going to serve automatically the content in Spanish. So basically that creator is already, without doing nothing, just clicking a button, is now reaching also Spanish audiences, when before it was only able to reach English speaking audiences. So, okay, this is the high level pipeline. Let's go deeper into that pipeline. And this is basically how we are going to do that. We are going to talk about the audio translation first, then we are going to add video into the equation, and then we are going to talk about productionalization, this experience, and what are we thinking, how are we thinking to evolve this experience. Okay, so in the heart of all this system, it's an open source model that we open source at Meta that is called Seamless. It's an ML model that basically that inputs audio and outputs audio in other language. So it's open source, you can Google it and you can find it. So this is at the heart of all the operations. So it seems that it's easy. We just send the PCM audio to Seamless, we get the PCM back, so we can go home and it's done. Okay, it's a lot of things does this model, but it's not that easy. So let's see what else we have to do to make it work. Okay, this is the audio only translation pipeline. So first of all, the audio, when it's uploaded, is encoded, some flavor of AAC, and then we need to decode it. We need to get to the PCM. We need to do some pre-processing. We will talk about that. Then we finally send the data to Seamless. Seamless translates this data. We need to do some post-processing. We need to encode it again. We need to max it with the video, and we need to create the AVR. So the gray boxes are very, very typical boxes that you can see in any video or audio video processing pipeline. So I think you all know about those. So let's focus on the blue ones. And one example that this is not as easy as it seems is that in these three boxes, there are more than 10, I cannot say the number exactly, but there are more than 10 ML models working next to each other to produce that final output that you just seen. So Seamless does most of the work, but it's not all of the work at all. Okay, so let's zoom in now into the pre-processing box and see what this box, see few of the things that this box is doing. First one is doing some early stage eligibility. So there are a lot of things that an audio that we know that if we send this audio to translate is going to produce a bad result. The obvious one is if the language is not supported. So if we detect that the input language is Hindi, in this case, and we do not support Hindi, we do one of those 10 plus ML models will detect that in a very early stages in the pipeline, and it will just error the translation, say, hey, tell the user, hey, this language is not supported yet, we support this and this and this. If the language is supported, we obviously accept the translation and the request progresses to the next stages. Another thing that the preprocessing does is sentence splitter. So Seamless is very good translating relatively short sentences. It was trained with short sentences, so around, I think it's 10 seconds, 15, more or less, but basically short sentences. And the reels, you can upload a reel up to 5 minutes now, and I think up to 3 minutes for translation. So basically, there could be a lot of sentences in 3 minutes. If we send 3 minutes of audio to Seamless, the output is going to be garbage. So we need to split the sentences in shorter. We need to split the whole thing in shorter sentences so Seamless can understand it. Let's put an example. Apple was red, he didn't eat the apple. Very, very simple, 2 sentences. So let's say another AI model analyzes those sentences and then produces something like that. So this does not seem like a very good segmentation. So Apple was red, he didn't, and then eat the apple. So if we send this to Seamless, it's going to produce a very bad translation because the second sentence has no context. I mean, it has a lot of context, but has not the right context. So we need to make sure that this step produces a good segmentation in order to provide the best possible translation. So in this case, it's very simple. The good segmentation is Apple was red, he didn't eat the apple. This, if we send this to Seamless, is going to produce a very good translation. So now we know we do some pre-processing. We split those sentences where we are still in the English domain if the source is English, and then we can parallelize Seamless and say, hey, translate all of these sentences to whatever is the target language. In this case, Spanish. But this is not all. We also have to do some post-processing. Now we have a lot of different PCM PCM data that we need to concatenate again and also do other stuff in order to finally produce the same audio, same length of audio as the input, but in Spanish in this case. So, problems in the challenges that we have in post-processing, alignment. So remember that in pre-processing we split those sentences. So now we need to put them together again. And this is now we are going to explain this challenge. And also retain the ambience. So if I just send the voice, so if I'm able first to separate the voice from the ambient noise, and I translate the voice and I create a translated content with only the voice, you will see that it's going to sound not very authentic. So we need a way to separate the voice from the ambient noise and then put it back. Also, if we send that noise to Seamless, it's not going to produce a good translation. So we need to extract that noise, send it to the post-processing, send only the clean voice to Seamless. Seamless is going to produce a nice translation, but without noise. Put them together, put together those translated sentences, and then add the noise, original noise, and then the translation seems, much more authentic. So let's see all of those steps. Here, the aligning challenge. So this is a huge challenge because it turns out that in different languages, to say the same thing, it takes different times. And when we talk about multimodals of video and audio, there are not only audio. So if we are translating audio, it's very simple. So I'm going to the store, goodbye, voy a la tienda, adiós. I don't care if the original took 10 seconds and the translation took 8. That's perfectly okay. It's just audio. But when we are talking about audio and video, look at myself right now. I'm talking and I'm just expressing, emphasizing what I'm saying, just moving my hand, moving my head. If I change the position of what I'm saying, even though I can change my lips, but my hands are now I'm saying goodbye. So if I'm saying goodbye, so it's going to look extremely weird. So we need to make sure or to do our best to align the sentences on the original sentence in time, the original sentence sentences with the translated sentences. And this is a multimodal problem. It's not always an audio problem because we can also change the words. So it's a very complex problem that we had to deal in the system. So basically, the correct thing to do in this case would be to basically expand a little bit the first sentence and then to align the goodbye with the adios. And this was, by the way, was a tough challenge, quite a difficult one. Retain ambience. As I said at the beginning, one of those pre-processing stages, we also make sure that the Seamless receives the cleanest possible voice in order to produce the best possible translation. But again, as I said, the final product, the final audio, to feel more authentic, it needs the original noise. So then we are sending also that noise. We bypass seamless, and we are sending it to post-processing to add it back to the final translation. Safety and integrity. So safety and integrity is something that we take very, very, very seriously at Meta. I'm not saying that because I work there, so I can totally tell you the amount of hours that our teams spend on that. So it's a real challenge, and we take it, as I said, very, very seriously. We spend a lot of hours to trying to making it as safe as possible, or as safe as we know. So basically, we did a lot of red teaming. For the ones that are not, they don't know what that means. So red teaming is basically having a lot of smart engineers inside trying to break the system. So basically, before somebody from outside breaks it, we try to break it ourselves, and we fix it, preventing from outsiders to break it. So we did a lot of that. We added also Mintox. Mintox is a model that we also open source, that it basically detects toxicity in the translation. So the ML models can hallucinate, as you all know. So we need to make sure that they are not creating toxic translations. So this model, before publish the translation, analyzes the original and the translation, and if we detect that it added toxicity, we error the translation, or we retry it again. There are several things that we do here. Watermarking. We add invisible watermarking to the audio to make sure that we can always detect that this audio was AI generated. We also add provenance metadata in the packager to identify that this audio was AI generated. And also we added reactive measure. We have a feedback flow for the user to provide the input, the feedback, that, hey, this translation is not accurate. We have also an approval flow. So we will not publish anything that the user did not approve. So if the user wants to approve all the translations, the user will, when the translation is ready, the user will receive a message, hey, this is the translation, do you approve or not? If not, it will never be published. Nobody will see that. And also we have an obvious option that is delete. If it was published, but then after the publish, the user detects that, oh, this is really bad, obviously they can delete that translation. So, and this is how the pipeline looks when we add safety and integrity. So now let's hear again the initial translation, but now without lip syncing.
Hola, mi nombre es Jordi Cenzano. Soy ingeniero en Meta. Y estoy aquí en Madrid para presentar cómo funciona mi trabajo de traducción.
Not bad, to be honest, because the sentences align, but now with
Hola,
lip syncing.
Mi nombre es Jordi Cenzano. Soy ingeniero en Meta. Y estoy aquí en Madrid para presentar cómo funciona mi trabajo de traducción.
So, okay, there is not a lot of difference in this exact example, but I can tell you that there is difference, but it provides a much better experience when you add video, when you add video to the translation. So when you also lip sync. So now let's talk about that. Let's talk about video. How we added video to the pipeline. So again, it's a multimodal experience that in the industry this has been solved just with using human translators that translates, that make sure that the sentences align with the length of the original, and then with professional dubbers that tries to mimic the voices or that replicate the voices of the original actor, and also coordinating the mouth movements. So here we try to do all of this. There is a lot of human work we try to do with AI, and at huge scale. So for in the film industry, for one film you have, I don't know, 5, 10 actors, and then 1 or 2 translators working on just that film. Here is just a machine that gets sees your face and replicates your lips, and does the best possible job. Not as good as the professionals, obviously, but as close as possible. So for that, we also needed to change our delivery stack. We'll touch on that, and our playback stack, because right now we don't have. We have one video and multiple audios, but with translations we have multiple videos with multiple audios. So on all of this, we needed to tell the players and signal all of this to the players, and also multiple renditions of every of those variations. So something needs to happen on the playback stack and delivery stack to make that happen. So this is the audio pipeline. So and this is the video pipeline. So with the max at the very beginning, we do some pre-processing because ML models are very picky on the videos spec that they are working on. So we need to do some data massaging before sending the data to the model, and then we do some post-processing, we encode the video, and we max it again to produce the final translation. But if we send only video to the lip sync model, it's not going to work. So a lip sync model needs also to know the translated audio, to adapt your mouth to the translated audio. But that audio needs to be clean because the lip sync model cares about the audio, not the ambient noise. So if there is some kind of train if you have some train in the background, so probably the lip sync model will think that is some noise and it will move your mouth. So we need to send the translated clean audio to the lip sync model to provide the lip sync model that information of the lips, but also lip sync model learns about you, about your mouth specifically. So we also need to send the original audio because the lip sync model will learn from that reel, from your mouth, your expression, and it will try to mimic that expression in the other language. And finally, for safety also we add a visible overlay to identify that this was AI generated and it's not real. So main challenges for the whole project. So the one, it seems quite obvious, but I have to promise you that it was not. And the second one, yeah, we'll touch on that, the challenges to put into production. So let's talk about the first one. So how we know we are improving? So should be obvious, isn't it? So basically you see it, it's better than before, we are improving. But how to know that at scale that we are improving the system? So there are different objective metrics. Objective metrics means that you have the original, you have the generated one, you put it into the computer and it tells you a grade for 0 to 10. 10 is perfect. So basically that's a perfect metric. If we have that, that would be perfect. We just constantly iterate on that. Okay, metric, the grade is getting higher, we are improving. But we realize that there are Basel, Blue scores, different metrics that they are out there. Just to do our due diligence, we ran those metrics, of course, but we also did some human evaluations. So like the ones that are all like me would remember those video rating cards to evaluate codecs from 25 years ago. So exactly like that, but with lip syncing and audio translation. So basically we had to find people that speaks the two languages, and then two languages because this was started in English, Spanish, and then rate those translations. And then we realized that the automated metrics, objective metrics, did not correlate properly with human evaluation. So basically all of this, we do all of this to please humans, not metrics, not computers. So we had to pivot and heavily rely on human subjective evaluation because those are the ones that they gave us a good signal on if we were improving or not. And then improve our objective metrics because obviously at the end of the day we want to automate that process. But we realized that we couldn't at the very beginning because this is quite cutting edge technology and the metrics are not yet there. So, and finally, for step changes, we realized that we needed to rely on senior matter experts. So rely on human subjective evaluations for iterative changes. It was very good, but for those things that will give us a step change in the long term, we needed senior matter expert point of view to get there. So model production. This is another good learning that basically we work a lot with research engineers, so very, very smart people. But they work on their research lab, that they have infinite bandwidth, they have uncompressed assets, specific frame rate, specific resolution, and they make these magic models work. But then when that model goes to production or wants to go to production, we have to acknowledge and realize that the world is very, very different than infinite bandwidth, uncompressed assets, no audio priming, perfect frame rate, and all of these things. So we need to adapt the data or the model to the data or the data to the model. And this is, so basically, and this is a lot of work, and basically to work very closely with those research engineers, and and also put the adaptation layers on top of the, or next to the models to basically get the best out of them. So this is some early feedback that we got from some our users. So it was quite positive. So definitely this is energizing. What else? I cannot share data, sorry, but I can tell you something that is common sense. So basically now, if you post something in English and it's auto-translated and lip-synced to Spanish, it's obvious that that post that you are uploading will have more reach. So we have more views because you now are reaching a bigger audience. So basically, this is what we validated with metrics, but I cannot share a specific number, sorry. Next steps, very obvious, better systems. So we want to platformize the platform that we built for this project. We are platformizing, better said, the platform that we built for this project. Platformizing means that any new use case, that does not have to be translation, any new ML use case will be now much faster to productionalize because we already built the building blocks. We already created the building blocks to make that happen. We also want to reduce latency, so make it faster. And better evaluation, monitoring, and QA tools. So basically connecting those production pieces to better QE and monitoring to connect that feedback of we are progressing, so this is better than before, so now let's deploy this. This is worse than before, so let's not deploy this. So basically trying to automate all of this and connecting to the production is a next step. We are getting there. Better user experience. So as I said before, we do this for the users. So expand the language support a music track. So basically when you add a music track in your app, we know the music track that you are adding, so we should basically be able to extract that music and remove that music and get only and get the voice. Multi-speaker, support multi-speaker. Right now we don't support that. And improve everything, so basically quality, improves the sentiment. By the way, you heard that we replicate also the voice of the original voice. So basically making it that more accurate, making it work with more noise, replicating the sentiment better. So all of these are things that we are targeting to improve. So that's all. So thank you very much for listening.